We will get going here. So welcome to our monthly webinar. For today we can. Hi, Mike. My name is Caroline, and with me I have our presenter, Mike Eisenberg, who will be doing our demo today. Before we get going, I just want to take care of a couple housekeeping items. The first is we will be doing a Q&A at the end of this session. But if at any point you have questions, just feel free to ask them throughout. And then the other item to note is that we're going to be recording this webinar, and we will make that available to you afterwards. And so with that, we are going to hand things off to our presenter, Mike. Here, Mike's a system engineer at Wavefront. I'll let him introduce himself and share his screen and get going.
Hi, everyone. My name is Mike Eisenberg. I'm a staff systems engineer for VMware. I'm focusing on the Wavefront product. Wavefront is a SaaS delivered service, cloud native, high performance metric monitoring and analytics platform. We provide high visibility through metrics, histograms, and traces. And really what that means is we can really give you a full stack correlation to allow you to identify problems very quickly. So again, we collect data from just about everything. We correlate it very quickly. We run analytics against it and then feed that data back to you in seconds. We're real time out of the box. We've got hundreds of native integrations, things like ServiceNow, OpenShift, you name it, we've got it. And if we haven't got it, we're probably going to have it relatively soon. We've got an 18-month data retention with no averaging. We don't roll data up. We keep it all raw data. We scale better than anybody. We can bring in millions and millions of points per second. And we've got great cardinality, which allows us to have very, very fast response and almost seemingly unlimited key value pairs. We've got a highly active, high availability architecture that allows us to bring in data at a very, very high rate and always be available. Today's accelerated application development environment creates monitoring challenges. You got rapid software change, the rise of container microservices. Every time you delete a microservice, it creates a new object ID when you recreate it. So if I clean my containers or rebuild my clusters, again, I'm going to have new object identifiers with those. Keeping track of where things are running and how they're running, and do they have the right resources, becoming a bigger challenge. Continuous delivery and Devops is going mainstream. And really what that means is whether you're doing a release once a week or once a day or once an hour, and we have customers that are doing all of those. Again, being able to quickly include Wavefront as part of your CIDC process, being able to automatically call Wavefront, be able to test with Wavefront, be able to automatically understand the state of Wavefront or the application through Wavefront, all through a programmatic interface is very important. Also, because we can bring in data from just about anywhere, we can give you a view, unified visibility, and understand where the area of impacts are with critical services. So we can see where a problem is coming up, quickly identify where that is, and be able to lead you directly to it. As I mentioned, we've got full stack capabilities. Again, we start out at business metrics and then can drill down to other services that those business applications are calling through application code, through a variety of distributed frameworks, all the way down to underlying infrastructure, giving you a single view of your entire environment. So what Wavefront gives you in many cases that our customers really like, advanced query-driven analytics, being able to drill into the millions of metrics that we have, and we're currently bringing in over 6 million or 64 million metrics per second across all our customers. So if you've got scale, we can do scale. If it's a smaller environment, we can definitely do that as well. Being able to bring that advanced query-driven analytics allows us to define and understand exactly what's going on inside the environment, clean up the data in case it's dirty, and be able to come out with the correct result. Now, that correct result gives us a couple of things. It gives us a clear understanding of what's happening inside our environment, but also because I can drill down so carefully, it also allows me to do proactive monitoring against past data and can do comparisons in real time, as well as create intelligent alerting that can be used for the start of automation. So again, I've got the ability to create these very specific alerts and run automation off of those alerts. Again, I mentioned the massive scale and availability. Again, across everybody, we're bringing in 64 million metrics per second today, and we can easily scale up well beyond that. We actually had a customer that had an outage. They were doing about 800,000 metrics per second with us, and they found their weak link in their internet connectivity. There was a backhoe, dug up a certain particular manhole, and it killed all their connections to the internet. Because this customer uses Wavefront every day as part of their daily release cycles, having our data available to them when they do those releases is very, very important. So once they repaired all the connections, they were able to, they had cached the data, and that data downloaded to us at a rate of over 4 million points per second. We scaled up automatically to support that. It was nice. They gave us a heads up that they were just going to clear the buffers, and we ran that for over 6 hours. So again, we did over 4 million points per second for over a 6-hour period of time, and we could have done that indefinitely. Also, Wavefront gives you the ability to have self-service metrics. So if I'm a developer and I decide that I need to count something or track something, I can actually just write myself a metric, do an HTTP put from my code. We can also include SDKs inside your builds, not required, but again, we can give you information about the environment with the SDKs, as well as you can just write these metrics out. And again, everything is available from a programmatic interface. I can create queries, I can use queries, I can test against specific queries, and I can use that result set all programmatically. The other thing we have is shareable dashboards. Again, these dashboards you'll see in the demo. And so I'm going to skip commenting on those for just a minute. Now, Wavefront is not an APM tool, but we really do a variety of things that overlap APM to a bit. And the way we like to describe this is that when metrics are lightweight, very fast, very responsive, they're kind of like the dashboard, the control, the cockpit of an airplane. I'm going to use it to fly the plane. The instrument's right there. I'm going to flip a switch. It's going to do something specific. I'm going to give it more gas. The plane's going to go faster. Logs are really more for crash investigation. After there's a problem, I'm going to use logs to figure out what went wrong. How much of a problem was it? But again, logs today expire very quickly. Most of our customers have reduced their log retention, except for security, down to 4 to 5 or 6 weeks. Again, reducing the amount of logs they keep because the code changes so fast, the log path, the path through the application that the log shows is not that important. The metrics that are kept within the logs, those are important, and Wavefront can parse the log files and bring those metrics in. True APM tool is going to give you everything in this kitchen sink. It's going to be a much larger agent. They can stack trace. They can provide a tremendous amount of data. It includes logs, metrics, tracings, synthetic transactions. They're big, heavy agents, and in many cases, very expensive. They're great for when I'm building an application from scratch. They're kind of like the blueprints of an airplane engine. I can use it to rebuild an engine or build an engine from scratch, but I'm not going to use those blueprints to fly an airplane. We've got lots of customers today using Wavefront. Again, all sorts of different types of customers. are using it, and in all sorts of different verticals. The data that we're collecting is really all about time series metrics. I will show you distributed tracing towards the end of the session, but again, what we primarily do is collect metrics around the environment. So we'll start out with a metric name. In this case, it's telegraph.apache.response.200.count, a standard internet standard for a metric name. The metric will have a data value of some sort, a timestamp to identify when it came in or when it was created, a source name on where it came from, as well as optional tags. Tags within Wavefront are relatively free and inexpensive, but they can also be used quite a bit in creating relationships and understanding where data has come from and how it relates to other data. But again, this is an example of a metric. It's tiny in comparison to a log file, so we can put many of those into a very, very small space. And in such, we don't have to charge for a storage of the metrics. The way we collect this data is a variety of different ways. We have the ability to both pull and push data. So in the case of another monitoring tool or a database, we can pull and query that database and request that data about the metrics for the environment. We can also have an agent, and we use Telegraph, an open source agent, but we can support any open source agent. Telegraph is the one that we prefer, but again, I've had customers that used collectd and a variety of others to bring data into Wavefront. We really just have to point that agent to Wavefront, and Wavefront will, the Wavefront proxy will then take in and do the appropriate thing with that. Again, we talked a little bit about development. Again, you can have custom metrics, derived metrics, automatically send a metric to Wavefront from any application. You don't have to pre-create it. We give you an API key. As long as you include that in the put, it all goes into the right place. And then you can query back on that data within seconds. The nice thing is that all this data becomes standard metric data within Wavefront, and it can all be correlated, time sliced, and shown together, all in the same dashboards or reports, or programmatically pulled into other applications. Lastly, we integrate with every cloud service. We're cloud-based ourselves, but we integrate with a variety of cloud services, and you'll see how we do that in the demo that's coming up. So I'm going to switch over to my browser. Again, we're a complete web-based platform. So everything within Wavefront is available through the web. I'm just using a Chrome browser to access my instance here. It's a demo instance within Wavefront. And what I've got here is, this is our integrations page. So our integration page starts out with a variety of tiles. These are the most popular ones, our featured ones here. You can also see the status, so you can see that we've got Docker and Kubernetes and Azure and Google Cloud Platform. We can also see that we're having problems with our Pivotal Cloud Foundry integration, but I've got a lot of other integrations here that are working just fine. These are really the easy buttons on how to create an integration, how to go into and collect data from these different sources. So I'm in the metrics section right now, but I'm going to go into my setup. Overview gives you a brief overview of what it's going to do, but I can see all my connections into Amazon through this demo environment. When I set up a new integration, all I have to do is give it a name, supply a role ARN from Amazon itself, and with that security context, I can then go out and access all the metrics that security context has rights to. Give it a CloudTrail region and just hit the setup. And off I'd go, be collecting data from Amazon. So I'm going to start out in the Amazon integration. So we can go in here, drill down, be able to look at the data, drill into a particular region. In this case, I'm looking at EC2 units instances within this Amazon region that I'm using. Here I've got a heat map of all the EC2 instances that I've got running. I can see that some are constrained and some are just fine. But I can also look and see, oh, it's a status check failed. Let me check more about CPU utilization. So I can reorder this and see via CPU utilization. I can also group these different resources by, again, like I said, tags. I'm going to select role, which is what we use, a name we use for applications. So I can see the different applications. I can see which servers are affected in which application, and I can go in, click on this, drill into this EC2 instance, get more data about what's going on inside that EC2 instance, and see what's happening there. So again, being able to drill down from my integrations page, being able to see what's going on. One other point that I want to bring out is not only do we bring on the base EC2 instance data, but we bring in data from a variety of services. We support 34 different services within Amazon. We've got just under 20 for both Google and Azure, and those are increasing as well. So again, we don't just do EC2 units, we're doing all the data about the different sources, whether I'm doing serverless or I'm doing database or any of the other services within, in this case, Amazon, or any of the cloud services. So one of the things our customers like to do is build dashboards that look like their applications. So here we can look at, we've got a sample application. I'm looking at the different components of that application. So I can see the front end. We can group our dashboards, show a variety of different chart types. I can see my Redis layers, the key space there, the MySQL database backend for that, any of the pods that are running inside this application. Again, it's a Kubernetes-based application in this case. And I can look at all the pods. I can look at the memory by pods. I can see the transfer rate, networking data, any data that happens to be within that environment. So my first real demo to show you some of the power in Wavefront is I'm going to do a correlation demo. So in this demo, what I'm going to do is bring up a set of 500 network switches. These are all top-of-rack switches in a data center. And the customer that we borrowed this data from, they actually had an outage between these two large spikes. The spikes actually don't have anything to do with this particular problem, but this is the time frame. They kind of pigeonhole the time frame of when the problem was. Now they know they had an outage, but they need to find what was responsible for that. One of the network engineers was able to identify an individual switch that had a problem. And we're going to call this the needle. So I'm going to look at that. We're going to call this particular switch. We can see that it went up from averaging about 2 million octets per second to well over 10 million octets per second. And if you have enough switches that are doing this, all of a sudden just pumping out a tremendous amount of data, it's going to crush your network no matter how fast it is. And what we want to do is, since we found this anomalous switch, we want to find out all the other anomalous switches that were working in lockstep with this particular switch. And what we're going to do is compare this needle, this particular one switch, to all the other switches that we're going to call the haystack. So I'm going to bring that one up real quick. We're showing that initially. And there's my haystack. So I'm going to I found that needle. And now I'm going to compare that needle to the haystack, and I'm going to correlate that so that I can see which other switches were having the issue. So again, what we're doing here is a quick correlation. We're using one of our functions, a moving correlation, over a 4-hour period, where I'm comparing my needle to my haystack, and I'm looking for within 75% of that anomalous switch. So what I've done is I found 4 other switches that were working in lockstep during the same period of time. And I quickly now know that these are my switches that could be causing the problem. Our customer drilled in a little bit further, and they found out the firmware on these switches was out of date, and that when they updated the firmware, it took care of the problem. Now we were super lucky. There was a network engineer who found the anomalous switch. They found the needle in the haystack, and we were able to compare against this. What happens when we don't have something to compare against? Well, what we're going to do is create a window of time. So I'm going to create a time range between the beginning of when we noticed the outage to the end of when the outage started to disappear. So now I've just created a window of time. Now I'm going to compare the haystack to this window and see what comes up. In this case, the same 5 switches. So I can find a problem, whether I've got a shape or I found the needle in the haystack and I have something to compare to, or if I don't, and I just have a window of time to compare to, I can see what's going wrong within that period of time. And that's what I've done here. The next demo I'm going to show you is really about how does Wavefront deal with data? How can we clean up data, make it more actionable? Because this is, again, another set of sample data that we borrowed from a customer, changed the name, of course, but they had a bunch of alerts. They had 5 alerts that turned out to be false alarms. These are data anomalies, but this is one of their key metrics coming into their environment. And what they had was, starting about 1:45, they had an actual outage where a set of customers was not able to get service during this period of time. The problem is that the operations team was so numb because of these false alerts that they didn't notice this problem until they started getting complaints from their customers. And unfortunately, those complaints came over Twitter somewhere about the midpoint, just after 2 p.m. So what I'm going to do is, we need to be able to take action on this data, but we need to clean up the anomalies and take some of the data out of this. So what I'm going to do is use some of the ease of use features here, and I'm going to clone this data point, because I want to leave this original one here. And I'm going to clone it, but I'm going to add in a function. Now, the way you smooth out anomalous data in metric monitoring tools for ages is to use a moving window calculation. And almost every other tool on the planet uses a moving average as their moving window calculation. I've worked on with probably 15 different monitoring tools. Each one of them have a moving average function, and they're able to select that and figure out what's going on inside their environment. And I'm going to apply this, and we can see that the moving average has really not added or taken away anything that's working here. So what I'm going to use here, instead of using a moving average, I'm going to use a moving median. Moving median is a much more elegant approach. I'm going to use a time window of 10 minutes. I'm going to apply that. And we can see right here that in the purple line is the original data. The green line, I've used the moving average, or the moving median, excuse me, to eliminate these false dips. And I still am getting a reasonable rate of change for this so that I can alert against it. So what I'm going to do here is I'm going to change this name right here, and I'm going to call this first. This is my first set of clean data. I'm actually going to make that a lowercase because I'll forget later, because we're going to use this again. And then what I'm going to do is I'm going to create another version of this, because what I really want to do is be able to use this data. So what I did was I just eliminated the view with the false alerts in it. And now I just have my nice clean data that I created with my moving median. So I'm going to clone this again, and I'm going to leave the median, but I'm also going to add another function. I'm going to add a time rate function, and I'm going to create a lag, and the time window for that is going to be a 10-minute lag. I'm going to apply that, and you can see I've got the exact same data, but it's 10 minutes earlier. So now what I'm going to do is I'm going to add another query, because this is nice. You know, I've got a nice drop here. I can say I can create an alert if it goes from, if I'm above 280 and it goes down to 260, I can have an alert and I'm really good. But this depends on having a certain level of volume. So what I'm going to do is I'm going to create an alert that is going to allow me to allow me to alert on any volume. So I'm going to say, I'm going to start out adding a variable, and I'm going to take my first, and I'm going to close that up. Notice it did an autofill, and I'm going to divide that first by my next metric, and that's my first clone, which is my data lagged by 10 minutes. And what this is going to do is create a rate of change calculation for me that will allow me to alert on any time. So I'm just going to put this in, and you can see the line here, but I'm going to change my scale. I'm going to do my axis to the left side and my axis to the right. Let me just turn these off. And what I've got here is a nice rate of change alert that will work on any volume at all. So I can see I've got my first alert, and then I've got my recovery time. And what we're doing is we're measuring a rate of change down to 0.9 or up to 1.1. So I can easily do, like I can do my first alert at my warning alert at maybe 0.97. I can do a medium alert at 94, and then I can do my critical alert at 91. And again, the system would automatically recover in doing that. So again, I can go out here, create that alert. And one of the nice things about keeping data for a long period of time is that if this wasn't sample data, we automatically backtest this alert to see how often that alert would fire. So I can actually go out and say, oh, it's firing too much. I'm making a noisy alert. So in this case, we talked about making this 0.97. And that's when my alert's going to be severe. Now I can add a target. Now the nice thing about this is I can do a variety of things as a target. I can create a ticket in my service desk. I can do a warning through Slack. I can even power an automation, because what I've done is I've cleaned up the data. And if I know what's causing that problem, I can automatically run the remediation for that with confidence that I've had the real problem and it didn't run the remediation against the false alerts. It's only going to run the remediation against the actual alert. In this case, what I'll do is I'm going to do a Slack alert. I can also add another target if I wanted to. Let's say pager duty. I want all hands on deck, so we're going to page people. I can also set up a smoke alert just for some warning. So I can do this 94, something's kind of going on here. And I might just say, okay, I'm going to just put this one out in Slack this time and really just create a Slack alert for this and just warn people that things might be going bad. So that gives you an idea of where I can use my analytics to first clean up my data. And then I can use alert off that analytics and be able to have a nice, clean alert where I can now safely run automation that I have confidence in running automation for. So the next demo that I'm going to show you is our code deployment alert. We have several customers that do code releases daily. Every time they do a release, they're checking a dashboard filled with charts like this. What they're looking at is, here's my code deployment. We can, even though we don't bring in logs, we can bring in critical events that are important to the environment. And we can see here that we've got a change from before the code push to after the code push, but we really can't quantify it. So what I'm going to do is I'm going to use one of the functions again. I'm going to do a simple aggregation, and I'm going to average this data together. Now we're looking at about 50 different servers. Now this could be functions, this could be services, this could be a variety of things. But once I do that, I can see very clearly that I've got almost a 50% increase in average utilization from before the code release to after the code release. Now, if I've done this on purpose, where I wanted to understand, I've added new features and it's going to use more resources, that's great. But if I've got a cloud-only environment and I haven't planned for this increase in utilization, I'm going to get a bill at the end of the month from my cloud provider who's going to be happily smiling and hand me that higher bill. So what we've got here is a possible problem. So again, it's good to know. But usually when you're troubleshooting this and everybody's sitting around a table or on a web conference trying to figure out, is this a problem or not? Somebody always comes up and says, hey, this is the same thing that happened last week. There's no problem here. And what you want to be able to do is understand very quickly, is this the same problem or is this different? So again, what I'm going to do here is clone this. I'm going to use my lag function again. And I'm going to do my time rate, select lag. Now, instead of doing 10 minutes like I did in the last one, what I'm going to do is change this to 7 days. And I'm going to apply this. So now I've got my original data from this week, but I've also in blue, I've got my data from this week, from last week, 7 days ago. Well, and while I can see the data is much more spiky last week, it certainly doesn't have that sustained increase that is even higher than the tops of the spikes in most cases. So I know that the same thing didn't happen last week when we did a code push. I know the problem is new and that we can address that from this release point of view. Lots of our customers use data like this. They do automated testing against this, and they'll be able to make go or no-go decisions. They'll roll out a canary cluster, see if it works, compare it to the older clusters that are still functioning and have users in their applications, see if they're getting the similar or different performance capabilities out of the new cluster, and make a decision within 5 minutes whether they are going to continue the rollout of the new release, or are they going to roll that new cluster back. So cool. That one worked out well. Let's take a look let's do the next one. The next demo I'm going to show you is all about query scale. We talked about our ability to bring in data very quickly. Now, I always run that one from scratch. And really what I've done here is I brought in 1 million points of data in relatively like a second and a half. So this data came in very, very quickly. So I'm looking at the data and I can see that it's set up as an average. But really what I want to do is I really want to go out and look at this slightly differently. I want to be able to, again, go out here and change how we're looking at this. So again, I'm going to come out here and change the format of this. So again, we're summarizing by average. And oh, by the way, I don't have 1 million points, 1 million pixels on my screen. So what we're doing is each pixel becomes an average of a point of this range of time. In this case, what we're doing is about 32 seconds worth of data, or 32 minutes worth of data in every pixel that we're showing. So we're showing the average, which is nice, but if I'm doing capacity planning, I really want to look at my maximums. I want to see what is that top bar I have to get by. Now, again, I'm looking at a year's worth of data. We're rolling into the buckets. And what we've got here are these two very large spikes. Now, this is important to know. I got to be able to see if I'm going to be able to support this with my current infrastructure, because again, this was a while ago. But what I can do is I can just continually drill in, and I'm going to grab a chunk of real estate, and this spike will get a little bit bigger and bigger. And what we're looking at here really is a 7-minute spike in a year's worth of data in over 1 million data points. So again, what I'm looking at, because we don't roll up data, we never give you your average week, your average day, your average Friday, your average end of quarter. We'll never do any roll-ups like that. We allow you to calculate them, of course, but we're not we always keep data in raw format so that we're able to go back in time and look at a 7-minute spike in history from a year ago. Again, very complex thing, but shown very simply. And the idea here is that I've showed you two things here. One is that I can bring 1 million points of data back in almost as quickly as we can ingest them into Wavefront, as well as do the math against them and not roll up data. Be able to keep all that raw data so that I can understand how my environment is running and then compare it to, do I have the capacity to be able to support that now? Now, the next thing I'm going to show you is a little bit different. We're going to go out and I'm going to select my distributed tracing demo. Distributed tracing is built on OpenTrace. Again, an internet standard. We can use anybody's OpenTrace libraries. We have our own set of libraries as well that give you some additional data, but we can pull a ton of data out of these OpenTrace data flowing into Wavefront. In fact, we get so much data, we learn about the relationships of the different components. So in this case, if you've got a containerized environment or a serverless environment, I can watch how those different components interact, what's called from what, and from that build relationships and then assign labels to them. So that's what I've done here. All I've done is, this is a self-generating dashboard, but I've assigned these labels to it. And this is my application for ordering beach shirts and shopping. And I've heard for this demo scenario that we've got a problem with the application. People are complaining that it's slow. So what I'm going to do is start out and I'm going to drill into the shopping component, and it's 6 different calls to other app components within my application. So initially at the top of the screen, we're looking at the request rate, the error rate, and the duration. Again, this is a dashboard that I did not have to build. This was automatically generated off the data that we're collecting from OpenTrace. Now I'm looking at my duration across a P95, and I can see I've got these big spikes, and I think these big spikes are related to my performance problem. So what I'm going to do here is grab one of these, drill into it a little bit, and I'm looking at a summary view. So I'm going to switch this from a summary view. I'm going to switch this into my detailed view so I can see the individual traces that are making this up. And you can see that I've got a variety that are well under a second, but I've also got a ton, or way too many, that are over a second. So again, 1.6, 1.7. And these are really the parts that look like they're running a lot slower and taking a lot more time. So what I'm going to do is I'm going to go into this shopping web resources for order shirts, and I'm going to go into that. I'm going to look at my transactions that are around those. Go back a quick sec. Go into my order shirts. I clicked the wrong thing. So the nice thing here is I get all my transactions that I'm tracking here, and I can click on any one of these and get the detail for them. Notice my longest ones are up front. I also get a map of the environment so that I can see what components are related to what. So I can see my shopping app is made up of styling and delivery, styling calls, printing, and packaging. And then what I've got here is my entire transaction broken down into spans. This is the individual calls that it's making from component to component. So shopping's calling shopping get calls styling, and I can see how long each component is part of critical path through the solid orange line in the middle of the bar, in the middle of a bigger bar. So you can see that I'm not spending that much time in shopping. I'm spending almost no time in the shopping get, but I do come back to it later on. But if I'm looking for where most of my time is going, that really comes down to gift wrap, because that's where the application is spending most of its time. So once I click on that span, I get all the tag data around that span. So I've got the relationship, where did it come from, what kind of service it is, what kind of component, in this case it's gRPC. And if I click on that, it will give me all the gRPC tags as well. And not only does it have that data, but it's also generated a dashboard for that packaging service app itself. So I can click on that, Notice it's very similar to the original drill and dashboard that I went to, but now I'm only looking at the packaging component. So again, I can scroll down. I can see that I've got my standard red metrics, my request rate, my error rate, my duration. And again, we do a P95 on the duration. But I can scroll down here and I can see my median response payload spikes during the same period of time that I had those slowdowns. Because again, I'm in the point in time, I'm in context for that. I get my requests and then I get a response. And as my response goes up, so does the time that I have for the thresholds. So what happens is my app is slowing down as I create bigger packets, it's slowing down. And while I'm not bringing you down to the individual line that has the problem, I've really narrowed it down to 2 or 3 lines of code within the application where it's loading the packet and sending back the response. So that ends the demo portion of today. Go back to the slides real quick. So again, Wavefront's got over 200 integrations. I think we're up to about 220 different integrations out of the box. Again, being able to integrate to pull data in as well as integrate going out, whether it's out to a message queue, out to a pager system, to Slack, to any service desk, and pull data in from a variety of sources as well. We're super good with containers and Kubernetes and serverless environments, because again, as I get rid of those, each one has a new object ID that can create cardinality issues within standard monitoring systems. So if you're interested in Wavefront, setting up a trial is easy. Go to wavefront.com. There's a free trial button on it. So all you have to do is hit that button for sign up. We also have blogs, the wavefront.com/blog, where it talks about metric monitoring, application visibility, and a variety of other good services that Wavefront can provide. And with that, I'd like to thank you for your attendance today. And again, I'm going to put back this slide in case you're going to write it down. Go to our website, sign up for a free trial, give us a whirl. We've got a great tutorial that will walk you through learning how to use Wavefront and even take you through setting up an integration and bringing in your first set of data. So thanks again for your time today. If there's any questions, could you please put them into the Q&A?
Yeah, we'll wait a couple minutes here while you type in your questions, but yeah, use the chat feature and we will be able to respond. We'll read them below.
So there's a question in the chat, but ask in the Q&A if you can. It says the waterfall that you show, is there a way to figure out what classes and methods are contributing more to the delay? Absolutely. So each function is going to be able to tell you how long it's there. So when you make individual calls, those calls are recorded. So as you make the calls through the environment, you'll be able to see how where the delays are. The other thing you can do is add your own metrics, instrument your code, so that you know how long that your code is spending or count where you are within the environment. Next question was, do you have the capability of a synthetic transaction or real user monitoring? The answer is to that today, no, we do not. But again, you can simulate the environment to some extent. We have the ability to check to see if URLs are alive, if they're functioning. We, again, based on error routines, we can fire off a webhook to run a script that could be a synthetic transaction, and then we can count the result of those as well. Other questions? Feel free to type your questions in the Q&A.
Q&A in chat, or if you want to raise your hand, we can even allow you to talk if you want to ask it live, either way. But
I didn't get that, Caroline. Can you repeat that?
oh, I say there's one more I just saw in here asking about our licensing policy and kind of how we do pricing and that.
Oh, that's an excellent question that I didn't cover. So licensing is by ingestion, not storage. We charge per metric point metric coming in. So when we bring in the first metric, let's say its CPU utilization is 50%, that's a point. If we bring it in a minute later and it's changed, that's another point. And a minute later, that's another point. So again, we add up all the metrics that are coming in per second. We do a P95 on it. This will, per day, and smooth out your any of the spikes. So any spikes that come in will be basically P95'd out. And then I'll be able to, we'll have a complete list of how many metrics are coming in at a time. And we break that down into chunks, and we charge you per chunk of metrics coming in. Again, we keep the data for free. We don't charge for storage. We don't charge for keeping the metrics, just for the ingestion of the metrics. Our customer success team will also work with you to reduce the amount of metrics that you have to bring in, because we find most of our customers over-collect data. They're collecting way too many metrics that are the same or similar that work in lockstep with each other. So we constantly work with our customers to slim that down. And our customer success team is a free service as part of being a Wavefront customer. Next question is, Wavefront only provides metric-based monitoring. What are the options for external monitoring like ping or HTTP checks? So we can use the Telegraph agent to do a ping test or an HTTP check as well. And as a result of that, basically just flag it and turn that into a metric, 0 being down, 1 being on, or a ping rate being above or below a certain amount. We can either go set that to 1 or to 0. And so you either get a positive or negative, and then we'd be able to either turn a square black or white, or just bring in the metric itself. If there's latency involved, we can check that as well. That was a great question as well. Thanks.
There. We are about at time. And so if anyone has any other questions, feel free to email Mike. You can see his email there. It's mikee@vmware.com. And he'd be happy to answer those. So I see a few more coming through. So yeah, we'll definitely we'll save the chat window and we'll send those forward to Mike. But we are at the hour. So I just want to thank Mike for presenting and for doing the demo, and to thank all you guys for joining. We really appreciate your patience at the beginning because we got this going, but glad you hung on. So with that, we will send you back to the rest of your days. Thanks for joining, and look for this recording in your inbox soon.
Thanks, everyone.